There are two kinds of changes that chemists are usually interested in, and these are called chemical or physical changes. So chemical changes are due to chemical reactions. A reaction is where you have one chemical to start with, and through the change, it turns into a different chemical. So, for example, let's look at rust. Rust forming on a piece of metal. The metal changes, usually due to oxidation, changes so that there's a layer of rust on it over time. And that rust is clearly different from the metal that it is resting on. So that is an example. So if I drew out what that looked like, let's say that we start with iron atoms. So here's some iron atoms. And then over time, oxygen gets in there. We talked about oxygen being diatomic. Here's oxygen molecules. And so they'll react together, and at the end, we'll end up with iron oxide. So let's say that we have oxygen combining with the iron to make some kind of iron oxide. So if you take a look at what you have at the beginning, you have this, and clearly that's different from what you have at the end. So we're changing our composition. We're changing from iron to iron oxide of some kind. So that means that the chemical itself is changing. All of these are examples of that. Silver tarnishing, same kind of thing. It's oxidation of silver. Combustion of a fuel. When you burn a fuel, you create combustion products. So picture gasoline, which is a kind of liquid, smells funny, don't want to drink it, right? When you burn that for energy, there's a certain point where you don't have any more fuel left because it's all turned into different things. Examples are carbon dioxide, which is a greenhouse gas, and water, and carbon monoxide, and sulfur dioxide, a bunch of different chemicals. So definitely chemical change when you burn fuel. Just like burning fuel in your body, so metabolizing glucose or sugar, digesting food, those are all changes that happen chemically. Baking and bleaching, also chemical processes. Baking, you're taking bread and you have a leavening agent, and like let's say yeast, and the bread rises, and that's because something's changing. You're making carbon dioxide usually. So baking, a lot of these are due to energy exchanges too. So baking is when you heat bread, or you make bread by heating dough and flour. So a lot of these processes you see energy being used or produced or both. Bleaching here, bleaching is to use chemical bleach, sodium hypochlorite, and that changes the color of our clothes. So those are all chemical changes. If we look at physical changes, these do not involve a change in chemical composition. So if you look at solid water called ice, and you melt it into liquid water, or you vaporize it into steam, whatever that is, it's still water though. So you're not actually changing the chemical. So you can chop something down, you can cut things in half, but it's still going to be the same substance. For example, I used to have pet hamsters when I was growing up, and I would feed them a little salt block so that they would get their minerals. So here's a little block of salt, and if I chop that block in half, you can see there's still going to be salt here and here, so it doesn't actually change its composition by cutting it in half. You can freeze things. Sublime means to change it from a solid to a gas. Melting means solid to a liquid. Okay, so it's good to know what these mean. Freezing means liquid to a solid. Condensing means a gas to a liquid. So like condensation, when you breathe your hot breath into a cold atmosphere, you get liquid Vaporizing would be liquid going to gas. And then deposition, probably very rarely hear about deposition, but that's how snow is created. So you have gaseous water in the atmosphere turning into snow, which is solid water. So these are all different changes. Notice that 3 of these are the opposite of the other 3. So sublimation, solid to gas, is the opposite of deposition, gas to solid. Vaporizing something, liquid to gas, is the opposite of condensation, gas to liquid. And melting something is the opposite of freezing it. All right, so here's some practice problems right here for you to try. Go ahead and pause the video, give it a try, and then we'll go over the answers. All right, so let's take a look at this. Number 1, label each of these as physical or chemical change. So tearing aluminum foil is just tearing it in half. That means whatever you have left is still aluminum foil. So I would say this was definitely physical change. Grinding coffee beans, that again, you're grinding, tearing, slicing, cutting, still coffee beans till you roast it or do something else with it. So definitely physical. Carving plastic, still just physical because you still end up with plastic at the end of that. Slicing a banana, still a banana. When you bleach your hair, you're changing the color of it. And change the color, you're changing chemicals. Different chemicals have different colors. So bleaching hair is going to be chemical. Rusting of iron, we talked about that one. That one is chemical because you're creating rust, which is the oxide of iron. And burning paper is kind of combustion, so this is also chemical change. Now, a lot of people say, well, what if it's both? You have a chemical change, like you bleach your hair, and you also have a physical change because it looks different. I would say chemical changes are usually accompanied by physical changes. So if it's a physical change only, then put physical change. If it's a chemical change, that means that it could be a physical change because of a chemical change as well. So you have pretty much those 2 options.